Hi everyone, and welcome to another video in the motion series. This video has a particular focus on velocity. This question, when it was first posed to me, actually gave me a bit of a problem. I must have been in year 11 or year 10, and it's good to have someone do it just so you know how to deal with it properly. Alright, the question goes, Michael drives a car south at 50 kilometers an hour for 30 minutes. So we don't know the actual distance yet. We've been given the velocity and the time. The velocity being 50 kilometers an hour, the time being 30 minutes. So we'll just draw an arrow there representing the distance he travels. Distance 1, we'll call it. And then he instantaneously speeds up and is now traveling at 80 kilometers an hour south for a further hour. So the first distance was 50 kilometers an hour for 30 minutes, and the second distance is going to be 80 kilometers an hour for 1 hour. And the second distance has a higher speed and a greater time, so it's obviously going to be a larger distance. So we have D1 and D2, and the details were the first velocity was 50 kilometers per hour, and the time was 30 minutes, and the second distance was 80 kilometers an hour, and the time was 1 hour. The questions we're going to ask is, first of all, we'll say, what is the total displacement? Then we'll find the total distance. Then we'll find the average speed. And then the average velocity. To find the total displacement or the total distance, we need to add up the distance travelled in the first leg and the second leg. Since they're in the same direction, we can just add one number to another. The distance travelled in that first leg can be found using the formula S equals velocity times time, or distance equals speed times time. The speed and velocity can be taken as the same thing in this case, because everything is happening on this one line. So the distance is equal to the speed, 50 kilometers per hour, times the time. We want the time to be in this unit here, hours. So instead of 30 minutes is actually 0.5 hours. So divide minutes by 60 to get it in hours. So 50 times 0.5 is equal to 25 kilometers. So that first distance Michael travelled in his car is equal to 25 kilometers. Not kilometers per hour, just kilometers. Now let's work out that second distance. The distance is equal to VT. Luckily in this case, kilometers per hour, and we have kilometers per hour, so the time unit is hours, and we have time unit in hours down below. So we can just say that's 80 kilometers an hour times 1 hour, which is equal to 80 kilometers. So that second leg is equal to 80 kilometers. So the total distance travelled, total distance is equal to 25 plus 80, which is equal to 105 kilometers. And since everything is happening on that straight line, the distance is equal to the displacement, because the displacement is defined as a straight line between the origin and the point at which we're looking at the object. And since it is in that straight line and the path doesn't wobble like that, the distance is the same as the displacement. So displacement is also 105 kilometers per hour. Now let's work out the average speed. It says up here the average speed is equal to the distance travelled over the time. Well, the distance travelled is 105 kilometers, and the total time taken to travel, well, that would be 30 minutes for the first leg and 1 hour for the second leg. So a total of 1.5 hours. So 105 divided by 1.5 comes to 70. So the average speed is 70 kilometers per hour. And since everything is happening on that straight line, the average velocity is the same. That's displacement over time, which is equal to 105 over 1.5, which again comes to 70 kilometers per hour. There hasn't so far been any difference between displacement and distance, and therefore there hasn't been any difference between speed and velocity. Let's look at a question in which there is a difference between displacement and distance. Okay. In this question, we have Michael travelling at 50 kilometers per hour over a time of 1,800 seconds south. And then he turns a corner and travels at 80 kilometers per hour east for a total time of 1 hour. And the questions are the same. First of all, total distance travelled, then displacement, then average speed, and then average velocity. Okay, total distance. What is the distance travelled in the first leg there? Well, distance equals velocity times time, which is equal to 50 times, 1800 is in seconds. We want it in hours, so we say 1800 divided by 60. That gives us in minutes. So divided by 60, 30 minutes. And then minutes divided by 60 gives us hours. So we have 0.5 hours. So T is equal to 0.5 hours. That's 50 kilometers per hour times 0.5 hours. Again, 25 kilometers. And that second leg we worked out before has a distance of 80 kilometers. So the total distance travelled hasn't changed. That would be 105 kilometers. The displacement, however, has changed. We have a distance of 25 kilometers in this direction and 80 kilometers in this direction here. The total displacement is defined as a straight line from the origin to the point where the object is existing at that time. So we're thinking at the end of the journey here. The length of this straight line here is going to be our displacement. And of course the length of that straight line can be given by Pythagoras. Displacement squared is equal to this side squared, so 80 squared plus 25 squared. So the displacement is just equal to the square root of 80 squared plus 25 squared, and that comes to approximately 83.82 kilometers. So the displacement is equal to 83.82 kilometers. The displacement is always going to be equal to this displacement is always going to be either equal to or less than the total distance travelled, because the shortest path between 2 points is actually a straight line. So moving on, first we find the average speed. Well, the total time taken is equal to 1.5 hours. The total distance travelled is 105 kilometers. So the average speed again is 70, average speed, 105 over 1.5, 70 kilometers per hour. That hasn't changed. However, the average velocity has changed. The average velocity is given by the displacement over time. So that comes to now 83.82 kilometers divided by 1.5 hours. 83.82. 55.88 kilometers per hour in that direction there, which I should specify, but I think that's a pretty good time to end the lesson.